Okay, good day, guys. My name is Siphiwe Mushwana. I'm gonna be helping you out with your physical sciences. Of course, so that your academic year can be simple for this year 2024. So I want us to start with our session for the day, and then now the topic that I want us to start with, of course, it's your momentum. So which is the first topic of the academic year of grade 12. So momentum, it's like a physics topic because we mainly have physics and chemistry. So momentum, it's your physics paper. So it's your paper 1 topic, which is quite easy, enjoyable, and doable. So I'll just start by explaining what is momentum, how do we calculate momentum, and all the factors that actually are within this topic, which is called momentum. So according to the definition says momentum, it's the product of the object's mass and its velocity. The product of an object's mass and its velocity. The product of an object's mass and its velocity. So now let me talk about this word, the product. So now product, according to mathematics, or this is now the word derived from mathematics, meaning the product is the multiplication. So in simplicity, so this is the multiplication of an object's mass and its velocity. So for you to can get the momentum of an object, it simply means you need to do two things. You need to multiply the object's mass, multiply it by its velocity. So two things that should be involved. For you to can get the momentum, I'll repeat this again. For you to can get the momentum, you need to be having an object. Now an object must have the mass, and secondly, it must have the velocity. So for you to can get the momentum of that particular object, then you need to multiply the mass and the velocity. So that's how we get the momentum. So now it's simply the product of an object's mass and its velocity. So in simplicity, you can just say it's the multiplication of the mass and velocity. So in so doing, you get what we call the momentum of an object. So the definition of the momentum actually give rise to the formula itself, because now the product of an object's mass and velocity, this gives you now how to calculate the momentum. So now this is now the formula of momentum, so which is P is equals to M multiplied by V. So I think by now you need to be able to have a picture of what's happening. So now let me just start by highlighting what is each and every symbol in this, so that now this can be easy. So P stands for your momentum. P stands for your momentum. So P stands for the momentum. Then the SI unit for momentum. But I think let me just start by showing you this other one, so that now I will show you what is the SI unit. So M stands for the mass of an object. So the mass of an object that we'll be using. So we know that the mass is measured in kilograms. So the mass is measured in kilograms. And then V stands for the velocity. The velocity, which is measured in meters per second. In meters per second. I hope you can see this. In meters per second. That is the velocity. Now let's go back to momentum. So P is your momentum, your M is your mass, then your V is your velocity. So now, because we are saying momentum is the product of the mass and the velocity, the multiplication of the mass and the velocity, which give us the momentum. What is the SI unit actually for the mass? So the SI unit is kg. What is the SI unit for velocity is meters per second. So actually the SI unit for momentum, it will be kilograms meters per second. So now this becomes the SI unit for your momentum. So it's basically just saying the SI unit for the mass multiplied by the SI unit for the velocity, which give you the total SI unit for momentum. So now this is your package for momentum. So momentum is just multiplying the mass of an object together with its velocity. Now, and then secondly, the second point that I want us to talk about, I think now you're just having a picture of this. Let me erase this. So now, momentum is a vector quantity. It's a vector quantity. Vector quantity. Meaning, in this case, like now, it is important that we have what we call the magnitude and the direction. It consists of the magnitude and the direction. So when you're calculating the momentum, you need to talk about the magnitude and you need to talk also about the direction of that particular object. So as I said, for you to have the momentum, there are two things that you need to have. So you need to have, firstly, there must be an object. An object must have the mass, and like now that object must be having the velocity. Be it like it might be 2, 3, 4, or 5. So, but then that object will be having a specific velocity for it to have a momentum. Now, a question can rise and say, what if like that object is just stationary? Like, let me just use this tissue for instance. So this is an object. Suppose the mass of this tissue. Okay, let me just write down the formula. So like now this is my object that I'll be using. So like this object like is just at rest on the board. So it's just stationary. It means the velocity of this, because it's stationary or because it's at rest, is 0, right? So if like it is 0 and then the mass of this, maybe it's 1 kg, just showing an example. So like it means I will say 1 kg, which is the mass of this. And then like now, what is the velocity of this tissue? So the velocity becomes 0 because like it's stationary, because it's not moving. So I will say multiply by 0. So like now it therefore means anything multiplied by 0, we know that is 0. So like actually it means the momentum of this object is 0 because it's not moving. Hence I said if the object doesn't have the velocity, so it means it doesn't have the momentum, or its momentum becomes what? Becomes 0. So anything that like has a 0 momentum, it means like there is no momentum for that particular object. I hope that makes sense. Let me give you like now the second example. Suppose now we gonna be having, okay, and I'm sorry, as I was still saying, like you need to consider like a specific direction. Like direction is very much important. So you need to specify, is it going to the left, right, up, down, east, west, or so on. So direction here is very much important. So you need to take one direction to be your positive direction. So this is how I choose the direction. I look at the initial motion. If this thing is going to the right, then I'm going to take right as positive. If it's going to the left, I'm going to take the left to be positive. But then like the other way around, direction actually like doesn't really affect your answer. But then you need to consider it. So like, let me just show you an example. Suppose now we are having an object. So now the object has a mass of 2 kg. So the object is moving to the right. And now the initial velocity that is moving with, or the velocity that is moving with, so this object is moving at a velocity of 10 meters per second. 10 meters per second. So this becomes the velocity that this object is moving with. So like now the question comes and say, calculate the momentum of this particular object. So the first thing first that I'm going to do is I'm going to take one direction to be my positive direction. So I will look at this and say, oh, this object is going to the right. So therefore, I'm going to take my right to be positive. Then automatically it makes left to be my what? To be my negative direction. So if I'm taking right to be positive, left automatically becomes negative. Because like now, if something is going to the right, then like the opposite direction of right, it's left. So like that's why left is negative. So therefore, I'll say P is equals to M multiplied by V. So I need the momentum of this. So now, because this thing I took right to be positive and it's initially going to the right, it means my initial velocity will be what? Will also be positive because it's going to the same direction. So I'll say momentum is equals to, what is the mass? So the mass of this is 2. What is the velocity? So the velocity is positive 10 because it's going to the right. So like 2 multiplied by 10, then this becomes 20 kg meters per second. So basically this is the momentum of this particular object. Don't know if like this makes sense. So like in this case, we are not yet done. So like now you still need to consider what? You still need to consider the direction. So like since like my answer is positive, so which side did I take to be positive? So I took right to be my positive. So therefore I'll say it's 20 kg meters per second to the right. So therefore this becomes a complete answer. So momentum, it's not only about the magnitude, but then also about the direction. I think I tried to explain or to simplify what is momentum. So thank you so much for this session. Hopefully then you'll join the next session, and please subscribe to our YouTube channel called like School of Science or like Siphiwe Mushwana. So just search the two, or School of Science. Thank you so much.